In section 7 of chapter 7, we are now going to be solving equations that have fractional exponents, as well as solving equations utilizing fractional exponents and fractional notation for the exponents. So it's nothing new, but there are a few hitches to it, one of which I want to review, which we've gone over previously, but I still want to review it. I want to remind y'all what negative exponents do, because it's a sticking point for a lot of Algebra 2 students. Not because it's necessarily or inherently difficult, but because it's been a while since you've messed around with them, at least algebraically. If you don't remember what negative exponents do, you at any point get stuck and you're like, oh crap, I totally forgot what negative exponents do. Here's the process by which you can figure out what they do. You set up an exponential. I have 2 to the x and 3 to the x, and you make a t-table. Because if I plug in negative 3 for my x, I would get the equation 2 to the negative third power. Now again, I'm assuming you don't know what that is. So we're going to pause on that, and we're going to pause on all the variants that have negative exponents. And just for funsies, I'm also going to assume you do not remember what 2 to the 0 power is, even though I know most of you probably do. This is how we determine what negative exponents as well as exponents of 0 do, is we first look at their positive counterparts. 2 to the first power is just 2. 2 to the second power is 2 times 2, which is 4. 2 to the third power is 2 times 2 times 2, which is 8. And then 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. The way we generate negative exponents as well as the exponent of 0 is we start doing some pattern recognition. If you notice, going from 2 to 4 to 8 to 16, going forward in our sequence, to get the next number, all we do is we multiply by 2. 4 times 2 is 8. 8 times 2 is 16. If I want to know what 2 to the fifth power is, 16 times 2 is 32. You can also generate the same pattern backwards. If going forwards in the pattern we're multiplying by 2, makes sense going backwards in the pattern we're dividing by 2. So 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and in case you forgot what 2 to the 0 is, all I got to do for my patterns is divide this 2 by 2, and that'll give me my next number, which is 1. Because anything brought to the power of 0 is always equal to 1. And then, if I want to generate the negative exponents, all I got to do is divide this by 2, and I will get the negative first power, which is 1 over 2. And then I would get the next one dividing that by 2, and I'd get 1 over 4. And then I divide that by 2, and I get 1 over 8. And you might notice that I color-coded these on purpose. Because all negative exponents do is if you look at their positive counterparts, all the negative does is it flips the value upside down. It gets the reciprocal. So what you can imagine is 2 to the negative 2 power is just 2 to the negative 1 times 2 power. That's 4 to the negative 1, which is just 1 over 4. And then 2 to the negative third power is just 2 to the negative 1 times 3 power, which is 8 to the negative 1 power, which is equal to 1 over 8. All negative exponents do is they take the value and flip it upside down. So if I have 3 to the x power, well, 3 to the 0 is 1, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81. Therefore, their negative counterparts are going to be 1/3, 1/9, and 1 over 27, respectively. I want to do a brief little recap because negative exponents do have a tendency to show up in these problems, and I don't want that to hold you back. So I want to do a quick little review recap of what negative exponents do, but also where they come from, so it's not just something you memorize, it's something that you understand. But here are 6 example problems that deal with solving functions using fractional exponents. So problem number 1, I have x to the third equals 27. Now I know you could all cube root both sides, but I want you to do your work using fractional exponents. We're going to bring both sides to the 1/3 power. Because a power to a power we would multiply. 3 times 1/3 is 1. Therefore they eliminate. You just get left with the x to the first power equals, and we look at this and say what one number times itself 3 times is equal to 27, and the answer is, of course, number 3. Problem number 2. I have x to the negative 2 power equals 25. I'm going to bring both sides to the negative 1/2 power because I want them to have a positive 1 for my exponent. And negative 2 and negative 1/2 cancel, and you get x is equal to the 1/2 power is 5, and then the negative power will make it 1/5. And there is my answer. Questions about that problem? There should be, because I did it wrong. The part that I forgot is the plus or minus symbol. A lot of students remember when you square root both sides, you have to put a plus or minus. They fail to connect that with fractional exponents. If the denominator is even, you need to put a plus or minus. If the denominator that you incorporated into the problem, it was not there at the very beginning, you put in the fractional exponent that has a denominator that's even, you need to incorporate a plus or minus sign. If you incorporate a fractional exponent and the denominator is odd, you do not need to incorporate a plus or minus sign. That's why problem number 1, I didn't throw that in there. So you need to be vigilant. These things rarely ever happen, but when they do, it's the difference between having half of the answers and all of the answers. So problem number 3, I have 2x cubed minus 1 equals 15. If I want to solve for that, x, I've got to get rid of the minus 1 by adding 1 to both sides. That'll leave me with 2x to the third equals 16. Then I've got to divide by 2, divide by 2. X to the third equals 8. Then I've got to bring both sides to the 1/3 power. 1/3 and 3 eliminate, and x would equal the third root of 8, which is 2. Problem number 4, I have x to the negative 1/4 power is equal to 3. All I'm going to do is bring both sides to the negative 4th power, because negative 1/4 times negative 4 is equal to 1. These will eliminate, and I'll just get x to the first power equals 3 to the negative 4th. When I do these in my head, I imagine it like this. I separate the negative 4 into its 2 components, the negative and then the number. I'm not trying to do negative 4 all at once. What I do is I look at the 3 and I bring it to the negative 1 power and the 4th power. You can apply them in whatever order. You could take 3 to the negative 1 power, which is 1/3, and then multiply that by itself 4 times. Or you can take the 3 to the 4th power and then take that to the negative 1. 3 to the 4th power is 81. 81 to the negative 1 power is 1/81. Problem number 5, I have the quantity x minus 7 quantity to the 3/2 power equals 27. I need to get rid of the 3/2 power first, so I'm going to bring both sides to the 2/3 power. My denominator is odd, so I don't need to incorporate a plus or minus. These exponents eliminate, and you get x minus 7 equals 27 to the 1/3 times 2 power. I can take the 27 and take it to the 1/3 power first, and then square that, or I can square it and then take it to the 1/3 power. I can apply these powers in whatever order I want. My recommendation, do the fractions first, because it's a lot easier to make a large number small and then big again than it is to square the 27. I don't even know what that is off the top of my head. And then cube root whatever number that would be. But I can take the 1/3 power of 27. That's just 3. And then 3 squared, that's 9. Add the 7 to both sides, and I'll get my final answer of 16. Then lastly, problem number 6. I'm going to subtract the 3 to the other side, because I get rid of addition and subtraction first, the reverse of PEMDAS, your order of operations. Then I get rid of any multiplication or division. I'm multiplying by 4, so I got to get rid of it by dividing both sides by 4. 2 divided by 4 is 1/2. Then I get rid of the power of negative 1/6 by bringing that to the power of negative 6. 1/2 to the negative 6th power. Well, 1/2 to the negative power is going to turn that into a 2. And then 2 to the 6th power is going to be 64. And that is my solution.